Good morning, guys. Today we are going to explore something interesting and practical case study. First, I want to say what is the title of case study. Here, the title that we are going to discuss is Network Traffic Analysis by Using Laplace Transform. This is the title that we are going to discuss as a case study. Okay. So before we are going to dive into get deeper understanding about this topic, let's have some small introduction about what we are going to do in this case study, right? Okay, here, first, what is our problem statement? That is very important, okay? So that we can get a clear idea about our topic, right? So here, I want to explain our problem statement through an real life example. So you just imagine when you are working on internet, like when you are watching videos on YouTube or downloading or uploading some files from internet, right? Or when you are making some video call to another person. So whatever the work that you are doing on the internet, definitely you might have the experience like when you are working on internet, the connection suddenly disconnect or even it gets stuck, right? So have you ever thought why does it happen? So that we are going to discuss today. Okay, and how to sort out this problem, how to fix this problem. That also we are going to discuss today, right? So here, first, why does it happen? It happened because too many data packets is being sent to the server at the same time, right? So when the server is too busy, the data packets have been in the queue, like we are in the queue in front of a bank counter or whatever it is, right? So here, by using Laplace transform, first this network is called network traffic. Okay, this situation, what we discussed now, is called the network traffic. So this is our problem which we want to fix it now, right? By using Laplace transform, we are going to fix this problem. Understand? So simply, I can say how the Laplace transform works here. So here we are converting our data from time domain to S domain by help of Laplace transform. So why we are converting the data from time domain to S domain? Because whatever the things it's being converted to S domain, we can S domain is nothing but which gives us the information in terms of algebraic operation. Once we have our information in terms of algebraic, definitely it can be sorted out in a short time or in easy way, right? So that is why we have gathered here that we are going to discuss about our topic. Come on, Vishnu, you tell me what is your insights about this topic?
As you mentioned earlier, every one of them are dependent on the internet. Everyone are using it for streaming, for seeing online classes, for playing games without computing. Internet should be available. So if many people are using it simultaneously, congestion and delays happen every time. So user experiences should be focused. They should improve the flows and notice how the delays happen, so that user experience will be improved and congestion will be reduced.
Exactly, you are correct, Vishnu. Come on, Surya, you tell me. So what exactly is network traffic and why does it need to analyze?
Actually, the network traffic means the to and fro movement of the data running at its simulated time. So, actually, we need to analyze the flow of data as well as the congestion points where the blockage of the data, so we can rectify the problem before the user notices.
Super. So come on, Tejaswini, you tell me what kind of problems occur if we don't analyze or manage traffic properly?
Yes, sir. Without proper analysis, we can face problems like data losses, delays during calls, buffering during video calls, and even server crashes, which affects both users and the service providers.
How does it help in a real world networking scenario?
Yes, sir. In real networks, the data packets may direct unpredictably. So, using Laplace transform, we can monitor the flow, predicting waiting times, and estimate how overload a server might become. So, this helps to making design decisions.
Okay, super. Exactly, you said. Now, Valentine, you tell me what kind of tools or models did you use while exploring with this?
So we have used a basic queue model where a server can handle incoming packets like people waiting in the line. We also used simulations in Python to visualize delays, and traffic behavior under different loads.
Okay, super. Now, Subiksha, you tell me, can anyone connect this with a real world application?
Yes, streaming platforms and cloud servers use similar models during traffic, during high demands. For example, Netflix prepare their server ahead of time for a big release based on a traffic prediction.
Okay, Tejaswini, come on, you tell me what you have understood. Come on, you tell me, what did you find the most interesting thing during this study?
So what stood out to me was how a mathematical concept like Laplace transform could be applied so practically. This made me realize how math and real-world applications are more connected than we think.
Super. Okay, Dharman, you tell me, how does the Laplace transform help with this analysis?
Laplace transform helps us studying network time behavior in more manageable way. It converts complex changes over time into simpler form, making it easier to analyze how traffic builds and how system responds to it.
Yeah, super, Dhananjay, exactly. So far we discussed about what is Laplace transform, what is network analysis, why does it happen, and how to fix this problem. So all those things that we have discussed. So we know very well what are the tools that we have to use to fix this problem. Okay, that also we have discussed. So you guys really you have a very good insights about this topic, right? So Darun, can you summarize what we have discussed so far?
Yes, sir. In this case study, we get to know that network trafficking is disturbing our day-to-day life. So we learned that from this case study that using Laplace transform, we are getting to solve the problems very easily.
Super. Super. As Dharm said, all we discussed, right? So I hope you will get a clear idea about this case study. So let's have a meeting in next case study, right? Okay. Thank you so much. Okay. Thank you.